I forgot to stop recording even though it's not required because all of you are here. I doubt like any one of you all gonna watch the video lecture right? Maybe not. If needed, then obviously it's over there. Um, and if Renzo ever showed up, he's still registered. He didn't show up after midterm at all. All right, so the topic for today's class is still the for loop. Still the for loop. What is going on here? I should be seeing the octave somehow. So octave, this one. Yep. So you wanna open this? Okay, everybody wanna open this new editor? What do you wanna do? Start to type the title for today's class. We would be doing for loop. Okay, for loops part 4. This is the 4th lecture for loop. Okay, and for while loop you'll be seeing again like 4 lectures. So title descriptions. So title description. Anybody want to do a project for this class? No. It's already too much with homework and practice problem, right? So there's this, I made your life so easy. Like the exam is take home now. You know that, right? The final exam is take home for this class. You like it, right? Who doesn't like take home? Everybody, right? All right. Okay. So I'll possibly put one question in the take home, a challenging one. Okay. It should sounds like a project, but not a big project. But a little bit challenging problem. This one. All right. So it's a complex series and plotting in loops. Then your main code. You know what to do on the main code. CLC. What else? Close. All. Clear. What does clear do? Clear all the variables, right? So you wanna do example one. I'm sorry. Example number 1. You're gonna write a cosine approximation. I'll write a function for cosine approximation. Okay, let's start with that. So the value of cos x can be approximated using this thing called Maclaurin series. What is Maclaurin? Maclaurin is a guy, right? A mathematician who invented this series for cos function. What is that series? So it is cos x equal 1 minus x squared divided by factorial 2. Now I know you may not even seen factorial yet. I'll talk about it shortly. Let me finish writing the series. Minus x to the power 6 divided by factorial 6 plus dot dot dot. Okay, take your time, finish it. Any of you ever seen factorial? What is factorial? You? When you know what is factorial? You may not. Let me help you. So factorial 2 means 2 multiplied 1. Factorial 5 means 5 multiplied 4 multiplied 3 multiplied 2 multiplied 1. Understand that? Factorial 6 means 6 multiplied 5 multiplied 4 multiplied 3 multiplied 2 multiplied 1. Factorial 10 means, you understand, right? 10 multiplied 9 multiplied 8 multiplied. That's what the factorial. That's a mathematical operator. The way you can represent it by exclamatory sign, right? That's called factorial. All right, so now this is the series, Maclaurin series. I did talk about it, right? Maclaurin is a mathematician. He invented this. Okay, he said that okay, cos can be written as this way. Famous mathematician. So now, as you can see from the series, it just follows a pattern. First pattern is plus minus, right? Plus 1 minus x to the power 6 plus x to the power minus of 2%. So that's one bracket. What is this other bracket? Is x to the power 2, 4. So x to the power 0, 2, 4, 8. That's the pattern, right? Okay, the same thing is a factorial number, right? So like 0, factorial 0 is 1. You know that, right? You should know, since you said like factorial. Factorial 0 is 1. Okay? Factorial 0 means 1. So factorial 0, factorial 2, factorial 4, factorial 6. So you see the way it goes, like if you are assuming like for I equal 1 colon up to whatever number infinity, right? Then this I value, if it varies from 1 to 3, 4, right? That's the way. So you should be doing like on this for loop inside for the code itself, should be writing like for the factorial I'm saying I multiply what? I multiply what? 2, right? Make sense? So I multiply 2 is 2. 1 multiply 2 is what? 2. 2 multiply 2 is 4. 3 multiply 2 is 6. You see that pattern? There is a problem. The first number doesn't do that, right? So your second number is what? I multiply 2, right? So you should be doing something similar to I plus 1, where I should be starting from 0, right? Something you gotta do, right, in the for loop code, which we'll be seeing shortly. But before I do anything, right, you gotta make your strategy straight, right? These are the strategy, right? How you may crack this. Three things: plus minus, then this factorial thing, right? Like and finally this x to the power thing. So these three things you need to crack. All right, so let me give a little bit of brief or more about it. Okay, so I'll come to that when we're going to start writing the for loop. But for now, let me give you a little bit of more theory. So which can be expressed so more compactly. So this series, right, as so you have this so if the summation of k, remember I, j, k, l, m, n, those are the variable that you use to define. So that's the k. Okay, k starts from 1 to infinity. Remember infinity because the series always goes up to infinity, right? So if you assume that way, then it can be written as minus 1 to the power k minus 1 multiplied x to the power k minus 1 multiplied 2 divided by k minus 1 multiplied 2 factorial. Make sure all those parentheses matches. Okay, so the way easiest way to check with the parentheses matches, if you put the mouse cursor to one of the parentheses, the other parenthesis is going to highlight. Okay, so that's how you know it's matches. Okay, you understand? You want to check whether all the parentheses matches. Okay, so that's good. So that's the series summary, right? We'll be writing this code inside the for loop shortly. So we'll be recalling that the symbol epsilon stands for factorial, right? So use a midpoint break loop to determine how many terms must be included in the summation, okay, in order to find the correct value of cost 2 within an error of 0.001, limit the number of iterations to a maximum of 20. So that's the theory. How we're gonna do that strategy, in other words, right? Solve it. You'd like to assign like the precision, which is 0.001, right? And number of iterations like 20. And then you'd be asking the user to define a input function x for the user to put the value that you'd like to explode the cosine value, right? So please enter the value in radians, right? Make sure the cos is for radians, cos is for degree, remember that. So in radians to compute the cosine of, that's what you are asking the user, right? Yet so far. So then you are defining, since the problem says don't do the iteration more than 20 times, so defining the maximum number of iteration, capital N is 20. So that's the define the number of iteration. All right, then you are defining this sum cost is a variable, is 0. Remember we did use it total before, like total equal to total plus something, right? The same thing is sum cost here, or summation of cosine function. Okay, so you are initialize variable for summing the terms. Okay, and those who are advanced, I'm just starting it for you. For k equal 1 colon n, right? And then and I would like to just give you the structure here, right? For those who are a little bit advanced in this aspect here, so you'd like to do if statement here, if, so if the absolute value of cos x k is less than 0.001, where this 0.001 is the convergence. I'll talk about more about the convergence, okay? Criteria need to use absolute. You know, absolute is a function, ABS, right? Absolute because half of the terms in the series are negative. You know that already, right? Because -1 plus x squared 2 factorial minus, so this way plus minus, so half of them are negative. So we want to know the absolute value, right? Absolute value. So what happens when you have this thing converge, or the value is less than 0.001, then you're gonna use this function called break and end this. Okay, and this last end here is for the for loop. This and is for the if statement. So you'd like to write if statement and for if statement and this break. I'd like to put a note for this break. Break will end the loop. This is not ideal. This type of operation is probably better done with a while loop, but we will see that next class. Alright, so it is almost done. The two things that you gotta do, you gotta write this cos x function. Let's see how much you understand so far. So that line you got to write, and then you got to do sum cos equals sum cos plus cos x. Okay. So the second thing will be add the most recently computed terms. Okay, let's see if we can finish just one line that I had over there. So the main thing, the main code for the series. Okay, so where you had this, I do have this thing on the note as well, right? You should be able to finish it. All right, I did talk about the Maclaurin series, right? That's the cos expansion. Now after that, all right, after that, what I've done, I wrote this for loop, right? On the for loop, I had the sum cos. Remember, the sum cos is keep adding the value of the final result of the cos expansion, right? But before doing anything, I was asking the user, okay, what is the cos gradient value that you would like to explore, right? Is it like cos 2, cos 4, whatever, right? And then I was assigning how many times the loop needs to be done. The loop needs to be done 20 times, right? That was in the question. In the question, they have another important point, which is what? The convergence criteria. If you are familiar with the convergence criteria, the convergence criteria is like, convergence criteria is telling you how many times the for loop needs to be done. So how precise the result you want. Make sense? How precise of the precise results that you want, right? Yeah, on the series, you see after these three terms, what did I do? I add a plus and then dot 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 dot. What does this dot dot mean? That you can infinitely write the terms one after another, one plus term, one negative term. Do you understand what I'm saying? What does this dot 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 mean? It's infinitely you can write this term, right? Following the pattern, like x to the power 8 factorial 8 divided by x to the power 10 factorial 10 divided by this, infinite amount, right? But how many times you got to do it? Only 20 times, as the question says. Okay? And the question also says you not necessarily have to do it 20 times. You can end it any time if the precision is less than 0.001. Make sense? So if the precision goes, I don't want any precise than the result is, can you understand, right, what I'm saying? I don't want a result any precise than less than 0.001. What does it mean? See, like you have a result of 15.000206 or result like 15.0005. I don't care about 0.0005 or 0001. As long as the precision is 0.001, I'm good. How gonna make sure that the precision is 0.001? See inside the for loop, the first time I'm doing what, like that if statement, right? It's problem the first time. I did it before as well. So the if statement. What the if statement doing here? Jason? The if statement say every time the for loop is gonna run, you're gonna check the value of the cos x k, right? that particular value that we are exploring is less than 0.001. If it's less than 0.001, then you said like I don't care, I don't want to explore it anymore. Make sense? So you'd be seeing, surprisingly, you don't need to do the iteration 20 times. Okay? You'd be saying you don't need to do the iteration 20 times when you're going to run this. Okay? But I didn't quite complete the program. You got to finish one line. Can you do that? The main code. You did it? Did you run it? How many times did you run it? 7 times?
I didn't save it.
Save it and see. So do some work. Let's see. Can you understand everything, right? If you understand everything, try to write the undone portion of the code. What are you going to do? Write the code so you can represent the series, right? Again, what is in the series? There's a benefit of that. You see, I do have defined it in the text before, right? It's actually technically given. So I'm saying this one is technically given. So if I would be in your position, I'll be copying this. All right. Now I'll be pasting it here. Okay. But here's the thing that I gotta do. Instead of this factorial sign, MATLAB doesn't use this factorial sign. You gotta type this here. Factorial. See, immediately we start to write factorial. It did show up. And then you're gonna put a semicolon. Should be saving it. This is week 11, lecture 1. Okay, should be running it. It should be running properly. Is the error? Okay, 26. Okay, cos xk minus 1 to the power k minus 1. Oh, here's the thing. There is a bracket that I had to take it out. And there is this bracket. I have to take it out. Okay, then running it again. Now what? Line 32. What is the problem with 32? So break, B-R-E-A-K, break. It's not recognizing the break. Alright, let me see. Cos, oh yeah, here's the. I forgot to put another parenthesis now. It should be alright. So running it again. Yep, it is running. So X undefined near line 26. Line 26, X, oh, this X is undefined. Alright. So I forgot to take out this comment sign before the X. That's why it's doing it that way. Let me save it, run it. It should be running now. Alright, perfect. So cos x. Okay, 1 2 3 4 5 6. So 6 times it did run. I'm sorry. Now it's perfect. There is no more error. If you're going to copy exactly what it is, should be running 6 times, right? The cos x. If you're going to, it's running for you again. And if change it to and. try to get the some things here.
Also zero.
That one 0 as well. Sum cost. I have the sum cost negative 0.4162. Okay, what I'll be doing, I can it is good for you. I mean, there is no error, Ethan.
No error. Just
What is going on then? So cos x, if you're gonna click on one of these, so the absolute. Did you use the absolute function?
yep.
So click on this sum cost, click on x, see if it matches, right? Is it running for both two of you guys?
No cost two. Oh yeah. So you type sum cost. Enter. Yeah, you do have some cost. Type cos x. What did you do? Did you look at cos x? Or you did look at cos and cos x? Because cos has already a function in this one. Any luck? Ethan?
No.
Bring it up. You had this bracket. You see that bracket here, absolute. So you put the last bracket after this point 0, 0, 1. That's why this issue is happening.
What is that you
It's running for you. Just type 2 through. Looks like your one is working from the beginning. That's what you see what you're doing, as if like you're trying to find the value of the cost, right, in the calculator. Understand that? So this is, yeah, for you. Sure, we are good. Just one more problem left. Man, you'll be free for today.
Everyone understand what we're doing here, right? What did we do? We just write a function called cost, right? The one that you use all the time. You can verify that you are getting the right result or not. All right, so that's what you are gonna do next. I'm gonna verify. All right, so let's define oct cost, right? Octave cost as a variable name, like cos x, right? And then you'd like to display printf that you did it correctly. So the Maclaurin, right? Maclaurin series approximation is Maclaurin, is it an Irish name or okay? The next line is fine. Sum cost. Printf. So the octave or MATLAB, right? MATLAB result is, what is that result? Again, remember that percentage is the pointer, 0.6 is like that much precision you want. Bless you. And /n means new line. The cursor will gonna go to new lines. Talk about it pretty much every day now. You can say oct cost, right? That's the function. So that's the variable oct cost, and then you can save it. Okay, you can run it. You can type any value, and you should be seeing two results next to each other. Okay, and then you can compare how much of the difference of the results that you just create a function cost function, how much of the difference of the function value. All right, now the second example, it is going to take less than 5 minutes. Does everyone have last class notes with you? Jason, you were here in last class? So download the last class note from the Brightspace. Ben, you were here in last class? Open the last class note. Ethan, open the last class note, copy the projectile problem from last class note, because I'm gonna simply add one simple thing. While you are doing all of this, copying or getting the last class note, just try to understand what we'll be doing in this last example for today's class. Would be still drawing the, would be still drawing that in a projectile motion, but this time we'll be using a function called draw now. Draw now. Draw now. Yes. Okay. You got the class lecture JSON, like it says with the lecture 2. Okay. Good. Download it. Get that segment where the projectile portion, that example only, paste it here. If I be you, I'll be probably getting it this way. That's my last class note, right? I'll be copying that, the whole projectile example, I'll be pasting it here. Alright, so here I'm gonna rename it to example number 2. I'll be saying like plotting, and I won't be using the predefined matrix this step. So I'll be doing this plotting the projectile motion inside a loop. Okay, what I'll be doing next, I'm gonna keep this as it is, exactly as it is. I won't be touching any one of them. Okay, I will be deleting this, which in last class we learned, right, how to initialize the matrix. I'll be deleting those initialization. So I'll be keeping this as it is, the way you are seeing. Okay, I'll be keeping this as it is, all these things. So first the variable defined, then the vx, vy, and then the x and y. Okay, as it is. Okay, and then just before the end, I'll be doing this plotting. I mean, this plotting that you have it here, I'll keep the last plotting, but you see, Ben, what I did, I copied from last class, this last example, projectile motion, and I pasted it here, and I deleted some of the lines from there. Whatever you're seeing it here, right? So what did I delete? I delete the, once I pasted it there, I delete this section, initialization section, right? You see that what I'm doing? I delete this section, right? And I'm adding something here. The goal is, and also I changes the title. Okay, the example 2, plotting projectile motion inside a loop. Okay, then what I'll be doing next, I'll be doing a live plot. That's the goal for this class. So live plot. So plot xi yi, right, comma quote o. So that's the thing I'm plotting. Every time the for loop will gonna run. So then I'm gonna type this axis function where I'm defining the axis values from 0 to 1700 and 0 to 120, not the 17,000, 1700. Okay, and then I'm gonna use this command called draw now. Just like hold on, draw now is another command, right? Or CLC, it is like a command. And I'm gonna keep the other thing as it is. So these are the 3 lines that I'm adding, and I deleted some of the lines and I saved it, and if I'm gonna run it, right, then it has a syntax error. 70.
You forgot the second and parentheses on the very first line, 69.
Here?
Yeah, you forgot to end it. You have 3 opens with 2 closes.
Oh, sorry. I got it. Okay, should be running now. All right, you see the projectile is moving, right? Everybody see that? I probably didn't notice. Let me show it to you again. Interesting thing will happen. Okay, so 2, you see a projectile is moving. You see that? That's the draw now is doing. And after that projectile movement happen, what is happening? I have, after the for loop, I have the plotting again. So that is giving me the black black plot. Okay, but the draw now is doing it like, you know, when the for loop is running. Every time the for loop is running, what is happening then? You know, that ball or the circle mark is moving. Okay, that's it. That's all class. Okay. Yep, I was talking with the time I was talking with Jason as well. Like, you know, I'm applying for the promotion. So after this class review is great. Then just do that. Do the class review. Okay, I'm applying for the promotion.
Class review. Is there any price?
It will gonna come sometimes, right? During this semester. Do the class review. Make sure you do that. If you have something good to say, just put it over there. This is the promotion. Thank you. Oh, I'm sorry. What just happened here? Here, sorry. You got that? So first thing first, the title. It means then you need to change the title.
I have a question for the other class. How do I import?
Let me get my glass. I'm almost blind now. Without glass, I can't see anything.
How do I import blocks? The other drawing.
First of all, you gotta get those blocks first from the practice space. You have it saved somewhere. Okay, but yeah.
So I need to like.
Let me show you. So
Save it to my computer.
class exercise, see text material. Make sure you download this one. It's there. Go down, see. Yeah, the sliding doors was already there. It was here as well. Oh, that door. Yeah, sliding door. Yeah, you're right. Yeah, you're right. The garage door, right? Yeah, everything is there. So that was the location. You want to set materials? Go down.
I would get it in the drawing.
Yes. And then click on the this shows up. These doors are here, right? And you will make sure whatever you do, yeah, it's not that bad, right? You have the book, right? You have the physical copy, or yeah, just go all the instructions. It's very tedious. You can watch the video lecture as well. I tried to do the video lecture properly, but you know, sometimes I'm walking all around, so it's hard to do a good video lecture. But anyway, it should help. It should help you. So let me try to stop the recording in this case. So the recording